Training large language models. Data preprocessing. Data cleaning and tokenization. Data preprocessing involves cleaning and formatting raw text data before training. Common preprocessing steps include removing special characters, lowercasing text, and tokenizing sentences into words or subwords. Vocabulary construction. Constructing a vocabulary involves mapping words or subwords to unique numerical identifiers, IDs. Rare or out-of-vocabulary words may be replaced with a special token during preprocessing. Batching and padding. To improve training efficiency, data is organized into batches, where each batch contains multiple input-output pairs. Input sequences within a batch are padded to ensure uniform length, typically with a special padding token. Model training techniques. Objective function. Large language models, LLMs, are typically trained using maximum likelihood estimation, MLE, where the goal is to maximize the likelihood of generating the next word in a sequence given the previous context. Gradient descent optimization. Optimization algorithms such as stochastic gradient descent, SGD, or its variants, e.g., ADAM, RMS-Prop, are used to update the model parameters based on the gradient of the loss function with respect to the parameters. Learning rate scheduling. Learning rate scheduling involves adjusting the learning rate during training to improve convergence and stability. Common scheduling strategies include exponential decay, warm-up schedules, and cosine annealing. Regularization techniques. Regularization methods, such as dropout and weight decay, are applied to prevent overfitting and improve generalization performance. Dropout randomly masks out a fraction of input or hidden units during training, while weight decay penalizes large parameter values. Fine-tuning and transfer learning. Fine-tuning pre-trained models. Fine-tuning involves initializing the model with pre-trained weights and then further training it on a task-specific dataset. Fine-tuning allows leveraging knowledge learned from pre-training to improve performance on downstream tasks with limited labeled data. Transfer learning strategies. Transfer learning strategies for LLMs include feature extraction, where the pre-trained model's embeddings are used as input features for downstream tasks, and fine-tuning, where the entire model is fine-tuned on task-specific data. Benefits of fine-tuning. Fine-tuning pre-trained LLMs often requires less computational resources and training time compared to training from scratch. It enables leveraging large-scale pre-trained models trained on diverse data sources, leading to improved generalization performance. Challenges in fine-tuning. Choosing the right pre-trained model and fine-tuning strategy depends on factors such as the similarity of the pre-trained model's domain to the target task and the availability of labeled data.